of x. F we have substituted here. So this is the general differential equation for deformation of a bar. This is the general differential equation for the deformation of a bar. So next we will try to derive the exact solution for axial deformation of a uniform bar, right? So for that we will consider a cantilever beam fixed at x is equal to 0. Length of the beam shall be L, right? And this axial force can be written as Q of x is equal to C into x, right? Where C is a given constant and P the load applied at the tip, right? This Q of x is varying across the length of the beam, right? So this is a boundary value problem. Okay, we can, because here there is no time term involved. If t is involved, we can make it as an initial value problem, but this is a boundary value problem, right? So this our general boundary value problem can be stated as A into du by dx. This equation only I am rewriting. A into du by dx becomes d square u by dx square, right? Du by dx becomes d square u by dx, whereas q of x has become cx. Above general solution only I am writing. So this is valid for x is equal to 0 to L, right? For all positive values of x, it is valid for all positive values of x up to L. By using the boundary condition at x is equal to 0, that is u equal to 0. Since that x is equal to 0, it is fixed, right? We use the boundary condition u is equal to 0, right? Since at the right end P acts at x is equal to L, we have at right end force P is acting, right? Because of that, at x is equal to L, right? X is equal to L, we have AE into du by dx equal to P, right? So this is the equation from strength of material, right? At x is equal to L, P is equal to AE into du by dx, right? So this is derived from the equation axial deformation is equal to PL by AE. So P length is dx, L, PL divided by AE. U is equal to PL by AE. Since we have considered only elemental length dx, right? L equals to dx, we can write here, right? From the PL by AE, this expression is derived, right? So here delta is equal to PL by E. From the equation of delta is equal to PL by AE, right? From delta is equal to PL by E, this du is delta, dx is L. That is the difference, right? Then in order to find out the exact solution, we need to successively integrate the governing equation, right? So this is this governing equation we need to successively integrate. First time when you integrate, A into d square u becomes du by dx plus c into x becomes integration of x is x square by 2 equal to one integration constant c1. Again differentiating this equation, right? AE into du becomes u only plus c into x square becomes x cube by 3. So making it x cube by 6, this term c into x cube by 6 equal to c1, integration of c1 is c1x plus c2. Then simplifying, u of x will become this expression. This is the final expression for u of x will get. Then we need to find out the integration constant c1 and c2. In order to find out integration constant c1 and c2 at x is equal to 0, u equal to 0. We all know that this one, right? At x is equal to 0, u equal to 0, right? Therefore, we can write c2 equals 0. Okay, at x is equal to, if substitute x is equal to 0 in this above expression, right? So this c1 becomes c1 into 0, 0 minus c into 0, 0, remaining is c2, right? And u also 0, therefore c2 equal to 0 you will get. and at x is equal to L, we can substitute P is equal to